Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the strangest and most beautiful ideas ever whispered by science, the world of the quantum. It's a world that hums beneath everything you can see, where reality behaves like a dream written in light. Here, particles drift like possibilities, waves turn into things, and certainty itself becomes a polite illusion. But before we begin gently unwrapping this mystery, please take a moment to like this video and subscribe, only if you truly find these calm explorations enjoyable. And when you're ready, leave a quiet note in the comments to tell me where in the world you're listening from and what time it is for you right now. It's always such a comforting thought, knowing that as you listen, somewhere out there, someone else is lying awake too, all of us connected by curiosity and perhaps by the quiet hum of the same universe. Now feel free to dim the lights, pull a blanket a little closer, or let the soft hum of a fan become your companion. There's no rush here. If your mind begins to wander, that's perfectly fine. Let it drift, like starlight across the dark. We'll still be here, gently unfolding the story, one calm thought at a time. You might think of reality as something solid and dependable, a floor beneath your feet, the steady ticking of a clock, the warmth of a lamp on your desk. But beneath that quiet certainty lies a realm that doesn't play by the same rules. In this hidden world, a single particle can act like a wave, spreading itself out in space, or it can act like a tiny speck landing in one precise place. It depends not on its will, but on how it's asked, on how we look. Imagine throwing a handful of sand across the floor, only to find the grains arranging themselves into a perfect ripple pattern, until you lean closer, and suddenly the pattern vanishes, replaced by single dots scattered like stars. That's the quantum world, a dance between knowing and not knowing, seeing and disturbing light and shadow. In the ordinary world, if you drop a ball, you can predict where it will land. If you throw two, you can watch both roll away. But in the quantum world, a particle doesn't really go anywhere until the act of looking gives it direction. Before that, it exists in a blur of possibilities, what physicists call a superposition. You can think of it as a shimmer of potential paths, all waiting for the universe to choose one, not by magic and not by human thought, but by interaction, by something touching something else, however gently. It's not that your attention shapes the cosmos, it's that everything, when it meets something else, defines itself in that meeting. The act of being noticed is what brings form from fog. This idea began not in myth or poetry, but in the practical world of early 20th century science, with people like Planck, Einstein, Bohr and Heisenberg, each puzzling over the behaviour of light and matter. They found that the universe doesn't move in smooth, continuous waves like water, but in tiny, discrete packets, quanta. Light, for instance, can behave like a stream of particles, yet also ripple like a wave. It refuses to pick a single identity. The truth is both, and neither, until measured. That duality, that soft indecision at the heart of nature, changed everything. Suddenly the cosmos was no longer a clockwork machine wound by invisible gears. It became something more alive, more fluid, more uncertain. Heisenberg once said that the more precisely you try to know a particle's position, the less you can know its speed. If you imagine trying to photograph a firefly in the dark, you can catch its location clearly only by using a bright flash. But the flash itself startles the firefly, changing its motion. That is uncertainty, not an error in your instruments, but a built-in kindness of the universe, a rule that protects its own mystery. Without that uncertainty, atoms would collapse, matter would vanish, and the quiet solidity of your world, this pillow, this air, this heartbeat, would dissolve into nothing. the gentle blur is what holds everything together. Quantum physics teaches us that at the smallest scale, the world is not made of fixed things, but of relationships. Tiny exchanges of energy, patterns of probability, endless conversations between particles and fields. A single atom hums with invisible vibrations, its electrons tracing delicate paths like notes in a cosmic song. The boundaries between things blur. What you call empty space is actually alive with energy, a restless sea of virtual flickers that appear and vanish faster than thought. Even the vacuum isn't silent. It breathes softly, as if the universe itself were dreaming. And yet, out of this strange, uncertain world emerges everything you know. The warmth of sunlight, the taste of tea, the gentle rhythm of your breathing, all of it built from the trembling foundations of something we can never fully see. The closer we look, the less stable the picture becomes, until it's no longer clear whether reality is made of matter or of mathematics, of waves or of whispers. Perhaps it's all of these, a grand balancing act between chance and necessity, chaos and harmony. As you listen, you might feel that same duality inside yourself, that mixture of knowing and not knowing, of being both observer and participant in the quiet unfolding of existence. That's the spirit of this journey. We're not here to solve quantum physics tonight. We're here to feel its rhythm, to walk through the fog with curiosity and calm, to let its strangeness slow us down instead of confuse us. For the deeper you go, the more the mystery softens, until what once seemed chaotic begins to sound almost peaceful. In the next step of our journey, we'll follow this trail of shimmering uncertainty into one of the most famous experiments ever performed, a simple test of light and shadow that revealed how the universe watches itself. But for now, take a slow breath and let the idea settle. The world beneath your world isn't solid at all. It's a soft haze of possibility, and somehow, that's what makes it real. If you've ever stood by a window during a quiet rain, watching each droplet race its own path down the glass, you've seen how order and randomness blend together. Some drops merge, others hesitate, and a few seem to vanish halfway down. At first glance, it looks like chaos. But in that small chaos, there's a kind of rhythm. Quantum physics lives in that same rhythm, part predictable, part mysterious, and always shimmering somewhere in between. It's the science of maybe, a world not of things, but of chances. Imagine for a moment that you're holding a single grain of dust suspended in sunlight. It looks still, but if you could shrink yourself down to its scale, you'd see that nothing about it is truly still. Every atom inside it quivers. Its electrons swirl not in neat circles but in hazy trembling regions, what scientists call probability clouds. The word cloud fits perfectly. It isn't a defined surface, but a faint outline of where an electron might be found if you look for it. Not will be, not must be, might be. Nature, it seems, prefers to keep her options open. In everyday life, probabilities belong to games of chance. You flip a coin and know there's a 50-50 outcome. But in the quantum world, the probabilities aren't guesses based on ignorance. They're woven into reality itself. Before an electron is measured, it doesn't secretly have a position we just haven't discovered yet. It genuinely exists in many possibilities at once, here, there, and everywhere in between. Only when the act of measurement occurs does the haze collapse into a single, solid now. It's like reality clears its throat and decides which version of itself to show. This is what physicists call the wave function, though here we'll think of it less as an equation and more as a quiet forecast. Not a storm report for the weather, but for existence. It tells you not where something is, but where it's likely to be found. And like any forecast, it changes when you look again. Every act of attention rewrites the map. as though the universe were politely updating itself in real time to match the questions you ask. In that sense, observation isn't interference, it's participation. You aren't bending reality with your mind, you're joining its conversation. That's why the quantum world feels alive. It's not a place of cold precision, but of gentle hesitation. You can almost sense the universe thinking before it acts. A photon, a particle of light, may travel like a wave spreading across space, touching every path it could possibly take. But the instant you try to catch it, to see which path it chose, the wave vanishes, replaced by a single event, a spark of light on a screen. The universe doesn't hide its secrets, it simply expresses them differently depending on how you ask. If you ask for a wave, you'll find a wave. If you ask for a particle, you'll find one. It's polite that way, and stubborn. Niels Bohr, one of the early pioneers, described this as complementarity. The world, he said, isn't built from opposites, but from partners, two faces of the same truth. Light can be both wave and particle, not at the same time, but not separately either. Like melody and harmony in the same song, each only makes sense because of the other. That idea confused Einstein, who famously resisted it. God does not play dice, he once said, uncomfortable with a universe built on chance. But over time, experiment after experiment has shown that the dice are indeed real. They're just rolled in a way that no human logic can fully trace. If you think about it too long, it might sound unsettling. A world that refuses to be pinned down. But there's something strangely peaceful about it too, because in a way, the quantum world mirrors our own lives. You wake each morning surrounded by possibility. You could choose one path or another, you could stay or go, speak or remain silent. Until you act, those choices exist like overlapping ripples, potential realities quietly waiting. Once you act, one path unfolds and the others fade. That's the same soft logic the universe uses at every scale. It's not chaos, it's freedom written into physics. Even in the most ordinary things, a cup of tea cooling by your bedside, the pattern of dust drifting through sunlight, the quantum rules hum quietly underneath. The tea stays warm because of vibrating molecules exchanging energy. Those vibrations come from electrons jumping between levels of possibility. The colour of the dust, the reflection of the light, the warmth you feel, all are quantum events scaled up to human size. You live inside this orchestra of probabilities every day, and you always have. You're just usually too large to notice the notes. One of the most poetic aspects of quantum physics is that it turns certainty inside out. The more we learn about the microscopic world, the more we realise that solid things are mostly empty space, held together not by touch, but by attraction and motion. If you could magnify your fingertip until you saw the atoms beneath, you'd see vast emptiness between them, like galaxies separated by distance. And yet, they don't fall apart. They hum together, exchanging quanta of energy, held in shape by laws that are at once mysterious and intimate. You aren't a thing made of matter, you're a pattern held by harmony. The strange beauty of it all is that quantum physics doesn't erase meaning, it deepens it. It tells us that the universe isn't static or mechanical, it's conversational. Everything interacts, everything influences, everything is aware in the quietest possible sense. A photon meeting an atom, a particle passing through another's field. These are not collisions, but introductions. The cosmos is a web of meetings so small they almost disappear. Yet without them, there would be no world, no warmth, no us. If we follow the thread a little further, we'll see this interplay of possibility take centre stage in one of the simplest and most astonishing experiments ever imagined. A test that showed, quite literally, that light can decide what it wants to be depending on whether anyone's watching. But before we wander into that mystery, take a slow breath and let the idea rest. The universe doesn't move from cause to effect in a straight line. It hums in a circle of possibility, and every time you look, that circle collapses into a single glowing point, the one you call now. Imagine a quiet room, a beam of light, and a small metal plate with two thin slits cut into it. On the other side stands a blank screen, waiting patiently. When light shines through both slits, you might expect to see two bright bands appear, one behind each slit like the shadows of two open windows. But that isn't what happens. Instead, a series of pale and dark stripes appears, fading gently into one another, like ripples made by two stones dropped into still water. Where the waves overlap, they strengthen each other. Where they cancel, the light disappears. It's as if the photons, the particles of light, had somehow spread out like waves, touching every possibility at once. The mystery deepens when you dim the light so low that only a single photon passes through at a time. One by one, these faint specks of light hit the screen. You might think, now that each photon is alone, the pattern will vanish. But no, after many have arrived, the same soft ripples slowly appear again. Each tiny particle, travelling in isolation, seems to have interfered with itself, as if it went through both slits, took both paths, and met itself on the other side. The light, it seems, has a secret life. To make things even stranger, when scientists place detectors by the slits to check which one the photon actually passes through, the beautiful ripple pattern disappears. The photons now behave like polite little marbles, choosing one slit or the other. Observation changes the outcome. Simply knowing which path was taken reshapes the result. It's as if the universe resists being watched too closely, as if it prefers to keep a little mystery to itself. The first time this experiment was performed, it felt almost like a cosmic joke. How could something behave both like a wave and a particle at once? How could the simple act of measuring it cause such a transformation? Even today, no one fully knows. The mathematics describing it are precise, but what they mean about reality remains open. You can picture it like this. The photon, before being measured, doesn't exist in one place or the other. It exists as a possibility spread across space, a soft vibration of chance. The instant it interacts with something, a screen, a detector, a stray atom of air, that delicate cloud of possibility collapses, and the photon chooses a single definite story. Not because it decided, but because the universe, in its contact, has finished the sentence. You might imagine the photon as a traveller wandering through a foggy forest. Every possible path lies open before it, each twisting gently between the trees. The moment it meets the edge of the forest, the detector, the fog clears, and one path becomes the one it truly took. All the other paths fade like forgotten dreams. That is the heart of quantum physics. The world exists not as a solid sculpture, but as a script constantly being written, word by word through interaction. In the larger world, this idea feels strange because we're used to things staying where we put them. A ball sits on a shelf until you move it. A cup of water waits to be drunk. But down in the realm of the very small, waiting itself is an illusion. A particle doesn't rest quietly somewhere. It hovers in a haze of maybes. Only when it touches the world, when it interacts with light, with air, with you, does it settle into being. Reality, in that sense, isn't a stage where things perform. It's a conversation where things arise. That conversation is what scientists now call interaction or decoherence. When something delicate and quantum, like a photon, meets something large and noisy, like a wall or a detector, the quiet harmony of possibilities is drowned out by the chaos of the macroscopic world. The quantum music stops, and the note becomes a sound you can hear. This doesn't require human consciousness, only contact. Every meeting, no matter how small, reshapes the flow of possibility into a single moment of certainty. It's comforting in a way to think of the universe as sensitive rather than mechanical. It notices, not in a human sense but in a natural one. Everything that exists is part of an endless chain of noticing. The light notices the slit notices the photon, and so on. The act of being touched is the act of being real. That means reality is less like a fixed object and more like a wave of awareness travelling through matter. We are part of that wave too. You don't stand outside this process. You're woven into it. Another ripple in the pattern. If we think about it gently, the double-slit experiment doesn't just reveal something about light, it reveals something about perception. It shows that the boundaries between observer and observed are not walls but thin veils. When you see the world, you're not looking at something separate from you. You're taking part in the event that makes it visible. The photons bouncing off your eyes, the air carrying sound to your ears, all of it is a conversation between your atoms and the atoms around you. The universe knows itself through interaction, and you're one of its ways of doing so. Some people find this idea unsettling, as though it means reality only exists when it's watched. But that's not quite right. The universe doesn't wait for eyes to appear. It simply unfolds through relationships. Things become definite when they meet, whether those meetings involve you or not. When a photon meets a leaf, it creates the colour green. When it meets your eye, it creates sight. When two particles meet, they create new ripples that spread across space. Everywhere, at every scale, reality is busy introducing itself to itself. If you sit quietly now and listen to the soft hum of the room, the fan, the heartbeat, the faint whisper of electricity in the walls, you can almost sense that same pattern unfolding. Every vibration, every sound wave, every tick of time is the sum of countless quantum meetings happening invisibly beneath you. It's not chaos, it's choreography, delicate, invisible, and continuous. The double-slit experiment, in its humble simplicity, was our first glimpse of that hidden dance. As we drift further into the story, we'll explore what it means for something to exist in more than one state at once, how the same strange rule that lets a photon go through two slits at once also explains the hidden potential inside every atom, every molecule even within you. But for now, let the image rest in your mind. A dark screen slowly filling with pale ripples of light, the universe quietly playing both sides of a game it invented itself. If we imagine that same experiment once more, the twin slits, the waiting screen, the beam of light whispering through the dark, there's a question that lingers in the air like faint perfume. Why does the pattern change the moment we try to watch? What does it mean for something to be observed? The word sounds grand and philosophical, but in physics it simply means an interaction, a moment when one thing touches another and information passes between them. Yet somehow those tiny exchanges seem to hold the power to decide what is real. Think of it this way. The world of the very small is like a pond at dawn, still and hazy. You can't see the ripples until a breeze passes over the surface, disturbing the calm. Observation is that breeze. It doesn't destroy the pond, it simply brings its potential into focus. A photon of light, before being measured, moves as a wave of possibility, a soft trembling through space. When it meets a detector, that encounter becomes a record, a point, a fact, a small piece of history. The wave is still there, but its story has narrowed to one particular line. In the larger world, this might seem trivial. You look at a lamp, and it remains a lamp. Nothing magical happens when your eyes meet it. But on the quantum scale, those glances are delicate negotiations. The act of being measured, by any system, not just human sight, changes what can be known. You can never know everything at once. The more precisely you trace one aspect, the more softly the others blur. It's as though the universe insists on privacy, always leaving some part of itself just out of reach, like a cat disappearing behind a curtain. And yet, this isn't a flaw. It's a feature, a balance that allows existence to breathe. Without that blurriness, everything would freeze. Atoms would collapse, electrons would spiral inward, and there would be no gentle warmth in the world, no colours, no time, no life. The uncertainty, the way the universe looks back when we look, is what keeps the story moving. The light remains alive because it can never be pinned down completely. If you picture the photon again, sliding through both slits like a whisper, it's not deciding which path to take. It's exploring all paths, playing out every potential version of itself. Only when it interacts with something, the screen, the air, or even another photon, does it settle into one moment, one reality. The act of looking simply becomes part of the experiment's fabric. You and the photon aren't separate things. You're threads in the same weave, both part of the same unfolding pattern. There's a phrase some scientists use, the participatory universe. It sounds almost spiritual, but it's not about belief. It's about connection. Every particle participates in the making of reality through interaction. Observation is not a divine act, but a conversation, an exchange of information. When two systems meet, the universe updates itself, quietly, automatically, like a story being written as it's read. That update is what we call a measurement, and once the story is written, it can't be undone. The pattern on the screen no longer holds waves of maybe. It holds dots of memory. In your own life, you experience something similar. Every time you notice a small detail, a flicker of candlelight, a passing thought, the sound of your breath, it becomes part of your story. Before you noticed it, it existed in a haze of possibility. Afterward, it becomes memory, something fixed and known. The act of attention changes not the world, but your relationship to it. And perhaps, if you look closely enough, you'll see that the same is true for everything, from galaxies to electrons. The universe is both dreamer and dreamed, observer and observed, endlessly reflecting itself through its own eyes. This doesn't mean that consciousness controls reality, only that relationship does. When one thing meets another, the universe takes a step forward in time. It's like a cosmic heartbeat. Touch, update, continue. Each collision, each photon absorbed, each atom exchanging energy with its neighbour. They're all part of the same rhythm. Even when no one's watching, the rhythm goes on. A star still shines in a distant galaxy, not because someone sees it, but because its particles are constantly meeting, constantly writing new lines in the script of existence. If you've ever walked through a forest at night with a lantern, you know how the light makes the world appear in fragments. A tree trunk emerges for a moment, then fades as you pass. The ground appears in your steps, then vanishes again. The forest isn't gone, it's just waiting outside the circle of your light. Quantum physics suggests that, at the smallest scales, the universe works the same way. It doesn't exist as a complete picture all at once. It reveals itself piece by piece, in the light of each interaction, in every small act of connection. You can think of this as a kind of cosmic hospitality. Reality isn't something that happens to you. It's something that happens with you. The light that reaches your eyes has already travelled across impossible distances, scattering, reflecting, merging. Each particle carries a quiet history of encounters, the story of stars, dust, and time. By the moment it meets you, it's already part of a long chain of observation, one that began billions of years ago. You're simply the latest listener to the universe's ongoing whisper. So when we say the universe looks back, what we mean is that the act of noticing goes both ways. Every exchange leaves a mark. Every photon that touches your skin, every vibration that reaches your ear, every particle that dances in your breath. All of them are pieces of a dialogue between what is seen and what sees. The quantum world isn't distant or abstract. It's in you, around you, and through you, every moment. From here, the story opens into the deeper layers of that dance, into the strange state known as superposition, where a thing can be many things at once, where every possibility hums softly before reality chooses a note. It's the heart of quantum magic, and perhaps the closest science ever comes to poetry. But before we drift further, take a moment to rest with this thought. The universe isn't a cold observer watching from afar. It's a warm, participatory sea of connection, where every glance, every meeting, every shimmer of light is part of the same gentle act of becoming real. Imagine standing in a dense forest just before dawn. The fog is heavy, and each step you take seems to reveal new trees that weren't there a moment ago. You look behind you, and even the path you came from feels uncertain, as though the forest quietly rearranges itself each time you move. That's not far from how the quantum world behaves. Nothing is fixed until something touches something else, and every observation reshapes the landscape. Reality isn't a single static painting, it's a living scene that repaints itself as you walk through it. At the heart of this strangeness lies an idea both simple and endlessly profound. The universe doesn't decide on a single story until it must. Every possibility exists in a kind of shimmering overlap, a state physicists call superposition. But here, instead of a technical term, you can imagine it as music that hasn't yet chosen a melody. Each note, each rhythm floats quietly, waiting to be played. Once the first key is pressed, the song begins. One version out of many that could have been. The double-slit experiment we just wandered through was our first glimpse of this principle. A photon passing through two openings behaved like a wave that explored every path at once. It wasn't torn between choices, it was the choices. Only when it met the screen, when the universe gently asked, "So, which will it be?" did it answer by becoming a single point of light. Until that moment, it existed as a blur of possibility, the same way a coin spinning in the air is neither heads nor tails, but both, caught in the dance between them. But unlike the coin, which we know will land one way or another, the quantum world never promises predictability. It speaks in probabilities, not certainties. A particle's position, its energy, its spin, each is described by a cloud of chances rather than a number carved in stone. It's not that nature hides the truth from us. It's that truth itself exists as a range of options, narrowing only when interaction demands it. The mathematics behind this idea can be complex, but the heart of it is almost poetic. The world isn't built from absolutes, but from maybes. If we follow that thought gently, something beautiful begins to emerge. You're surrounded by layers of superposition every moment of your life. In the microcosm, electrons hum around atomic hearts, in patterns that can't be drawn as neat orbits. They exist as soft clouds, spreading across space in graceful uncertainty. In the macrocosm, even your own choices shimmer this way for a moment, paths waiting for your attention to collapse them into action. You wake each morning with dozens of possibilities sleeping beside you. What to eat, where to go, what to say. Each choice is its own probability cloud, waiting for you to bring it into focus. When Erwin Schrödinger wanted to illustrate the absurdity of quantum rules when applied to large things, he imagined a thought experiment, a cat placed in a box, its fate tied to the outcome of a quantum event, a single atom's decay. Until someone opens the box, he said, the cat exists in both states at once, alive and not alive, suspended in quantum limbo. Of course, he never meant for it to be taken literally. He was poking gentle fun at how strange it all sounded. Yet, in a way, his cat became the most famous metaphor for superposition ever invented. The point wasn't that cats or people can truly be both alive and not. It was that, at the level of atoms, reality doesn't carry the same firm boundaries we see in our world. The moment something as complex and noisy as a cat enters the scene, all those fragile quantum possibilities collapse instantly. The environment itself, Air, warmth, vibration becomes a giant measuring device, drowning the quiet uncertainty in a roar of interactions. This is what scientists call decoherence, though you can picture it instead as a whisper lost in a storm. The quantum song fades into the everyday hum of classical reality. The world becomes definite again. There's something comforting about that too. The fact that you don't dissolve into a haze of probabilities every time someone glances at you means that stability has its own quiet power. The macroscopic world, with its chairs, clouds, and candle flames, is what happens when countless tiny uncertainties blend together until their individual maybes cancel out, leaving something firm enough to touch. You could think of it as quantum kindness, the universe smoothing out its own strangeness so that larger things like you can find their footing. And yet, those tiny uncertainties never disappear completely. They hum beneath the surface of everything, in the motion of electrons, the sparkle of stars, even the flicker of thought in your brain. Every second, the quantum and the classical worlds coexist, like two overlapping melodies. One, invisible and strange, the other solid and familiar. Together they compose the song we call reality. If we look at it gently, superposition is less about paradox and more about generosity. The universe doesn't rush to decide. It allows everything to exist in potential for as long as possible. That patient openness, that willingness to hold many truths at once, might be one of the most elegant principles nature has ever written. When you look around, you can see it reflected everywhere, in a sky that can be both day and night depending on where you stand, in music that carries joy and sorrow in the same chord, in human hearts that can love and doubt at once. Superposition isn't just physics, it's philosophy in motion. The forest of reality rearranges itself not to trick you, but to include you. You are one of the many observers walking through it, leaving footprints that become part of its shape. The moment you touch the world, you change it, not by force, but by participation. And as you move on, the forest quietly shifts again behind you, preparing new possibilities ahead. The path now carries us toward an even deeper question. What happens when two particles, once close, drift apart but remain connected as if distance doesn't matter? How can the choice of one instantly echo in the behavior of another across the cosmos? It's a mystery Einstein once called spooky action at a distance. And yet, it's one of the most quietly profound truths of nature. But before we step into that strange, invisible bond, take a slow breath and remember, in the smallest corners of reality, the universe doesn't hurry to decide. It waits, softly, until the moment calls for clarity, and in that waiting, it holds everything that could ever be. Picture two small particles born together in the same bright spark, a brief flash where energy becomes matter for an instant. Then, as if pushed by an invisible breath, they drift apart, travelling in opposite directions through space. You might expect that once they're separated, each particle would live its own quiet life, minding its own tiny business. But the quantum world rarely behaves so politely. Even when these twin particles move light years apart, they remain connected, as if holding invisible hands across the darkness. When you measure one, its partner responds instantly, no matter the distance. This bond is called entanglement, and it might be the most poetic idea physics has ever produced. It says that two things can share a single state of being, no matter how far apart they travel. Their properties, like their spins, directions, or energies, are intertwined. If you gently check one and find it humming a certain way, the other, wherever it is, hums in harmony. It's not that one sends a message faster than light. It's that the two are no longer truly separate. They're parts of the same extended system, like two notes of a chord that only make sense when played together. Albert Einstein disliked this idea intensely. He nicknamed it spooky action at a distance, and suspected there must be hidden information, something we weren't seeing that could explain the coordination. For decades, physicists wondered if he might be right, but careful experiments, first imagined by John Bell and later carried out with photons and electrons, showed that no such hidden plan exists. The results can't be explained by any influence travelling through space. The correlation is real and instant. Reality itself, it seems, is stitched together by connections that transcend distance. It's easy to hear this and imagine something mystical, cosmic telepathy or secret messages through the void. But the truth is both subtler and more beautiful. Entanglement doesn't let us communicate faster than light. It doesn't break any rule of nature. It simply reveals that the universe's bookkeeping is holistic rather than local. When two particles are entangled, their shared state is stored in the relationship between them, not inside either one alone. Like the halves of a single melody, you can't describe one without the other. Measuring one completes the song, even if the second note is played galaxies away. You can see small echoes of this in daily life. Think of two dancers who have rehearsed for so long that even when they're apart, their movements seem to answer each other. Or of twins finishing each other's sentences after years of shared stories. The link isn't supernatural, it's the quiet residue of shared history. Quantum entanglement is like that, but written into the language of physics itself. When particles interact, they share a chapter of reality that neither can rewrite alone. From that moment on, their fates are intertwined, not by communication, but by structure, as if the universe remembers their meeting. Modern science has learned to use this strange bond. In laboratories cooled nearly to absolute zero, photons and electrons are entangled to build the foundations of quantum communication. In these systems, information is encoded in delicate correlations rather than in signals. A change measured in one place implies what's happening in another, though no message travels between them. It's a gentle trick of logic, not a shortcut through space. Still, it opens possibilities. Unbreakable encryption, new ways to teleport the state of a particle, even prototypes of quantum networks that might one day link computers across the world using the most fragile threads nature has to offer. What's profound isn't just the technology, but the idea it rests on. Entanglement suggests that the universe doesn't consist of independent pieces. It's a web of relationships. You're not made of separate atoms stacked neatly together. You are the pattern formed by their interactions, and those atoms are in turn bound to the stars that forged them. Every bit of matter shares the same cosmic ancestry. In a literal physical sense, we're all entangled with the universe, not symbolically, but through the shared origin of energy and time. If you close your eyes for a moment, you might sense this connection. The light that warms your skin began in the heart of the sun, where particles collided and fused, entangling and disentangling in endless rhythm. The warmth you feel now is the echo of those quantum conversations carried across 93 million miles. Every breath you take contains atoms once part of oceans, comets, and clouds of distant worlds. The bonds between things don't vanish with distance. They soften into background music, still there if you listen closely. In the quantum view, the concept of separation starts to dissolve. Space doesn't divide reality, it stretches it. The emptiness between stars isn't a void, but a threadbare fabric holding their light together. When one star explodes, the whole pattern of the cosmos shifts slightly to accommodate the change. In this sense, entanglement is simply the small-scale version of a universal truth. Nothing exists entirely on its own. And yet, even with all its wonder, entanglement is fragile. The slightest touch from the environment, a stray photon, a molecule of air, can break the link, scattering the shared information like dandelion seeds. That fragility mirrors the human world. Our connections too can stretch across distance and time, but they require care to remain coherent. A conversation, a memory, a gentle thought about someone far away. All are small acts of maintaining alignment in the greater web. You can think of entanglement as nature's quiet poetry about togetherness. It tells us that relationship is more fundamental than isolation, that interaction is the true unit of existence. When you look at the night sky, you're not just seeing distant suns, you're sharing an ancient relationship with them. Their light carries evidence of events that shaped you long before you were born. In that soft light, the universe looks back through time, recognizing itself in your gaze. Our quiet exploration now turns to what this connection means for information itself, how the universe seems to compute its own story, using these gentle rules of possibility and entanglement. The same principles that bind two photons can also be woven into the design of machines that think in probabilities rather than certainties. But before we enter that new terrain, take a breath. Remember those twin particles drifting apart, their invisible bond unbroken. Somewhere between them, across the emptiness, is the whisper of a single shared truth. To exist is to be connected. If you think back to those two particles, still connected across impossible distances, you might wonder how the universe keeps track of such relationships. How does it remember who touched whom? Who once danced with whose light? It turns out, memory is not a privilege of minds alone, it is a property of reality itself. Every interaction leaves a trace, not as a visible mark, but as a change in the way the universe hums. Once two things meet, the pattern of their meeting ripples outward forever, blending into the quiet background of being. In this sense, the cosmos behaves more like a musician than a machine. Each new note doesn't erase the last, it builds on it, creating harmonies that persist long after the sound itself fades. Entanglement is one of those harmonies. It's a record of togetherness, a reminder that even after parting, the echo of connection remains. What we call information, that quiet record of who interacted with what, is never truly lost. It might hide, it might scatter, but it never stops existing. Somewhere in the tangled threads of reality, the story is still there. You can think of this memory as the universe's way of keeping balance. When one thing changes, another adjusts. When one pattern fades, another emerges to fill its place. That's why information, even at the quantum level, seems impossible to destroy. It can transform from a photon spin into a vibration, from a particle's energy into a ripple of heat, but it can't vanish. The universe is too careful for that. It's like a perfect librarian, archiving every whisper, every shimmer, every flicker of interaction since the first dawn of time. This gentle accounting gives rise to something extraordinary. The idea that the universe, at its core, might be a vast information system, a web that processes its own history. Not like a human computer made of circuits and screens, but as a living computation woven into the fabric of existence. Each interaction is a calculation, every atom a bit of data, every photon a messenger carrying its small truth from one place to another. When two particles entangle, they aren't just sharing a moment, they're writing a line of code into the grand program of reality. It's tempting to picture this as something cold or mechanical, but it's not. The universe doesn't crunch numbers, it sings them. Its information is stored in relationships, in the way things influence one another, not in the things themselves. And because those relationships are endless, the song never ends. This is why some physicists describe space and time not as separate arenas, but as the memory of interactions that once happened. The world, in a way, is the history of itself. Even the concept of now, the fleeting instant you call the present, may be nothing more than the newest page in that unfolding archive. When you watch a leaf drift through the air or a candle flicker in the dark, you're witnessing the universe processing its latest update, adding one more ripple to its infinite record. That's what physics calls causality. But here, we can think of it more softly. Each moment giving birth to the next, each breath leaving a trace that gently reshapes the air around it. This pattern of remembering doesn't only exist in the abstract. It appears in technologies we're just beginning to build. Quantum computers, machines that use entanglement and superposition not as curiosities but as tools. Traditional computers, the ones humming quietly on desks and in pockets, rely on bits, small switches that can be either on or off, 1 or 0. Quantum computers, by contrast, use qubits, tiny systems that can be both at once, like coins spinning endlessly through possibility. Because of this, they can explore many paths simultaneously. But it isn't magic. It's the same physics we've already met, dressed in engineering. Each qubit, often an atom or photon, holds a probability wave, a quiet forecast of outcomes. When qubits become entangled, their forecasts overlap, allowing calculations to unfold not step by step, but as a cloud of possibilities that collapses only when the final answer is drawn. It's as though the universe lends its own natural parallelism to our machines, letting them borrow its calm, shimmering uncertainty for a while. Still, this power comes with fragility. Just as entanglement breaks when the environment interferes, quantum computers must be shielded from the everyday noise of the world. A single stray vibration, a flash of heat, even the faintest whisper of air can erase their delicate states. That's why such machines are built in silence and cold. Some kept only fractions of a degree above absolute zero, where atoms move so slowly they almost forget to exist. There, in that frozen stillness, human hands have found a way to coax the quantum fog into computation. It's astonishing to think that we, who once lit fires to see through the night, now chill atoms to near nothingness so we can glimpse the heart of reality. Yet the two acts aren't so different. Both are attempts to understand the world by creating a small, controlled piece of it, to listen more clearly to the universe's voice. When you see pictures of these machines, their wires curling like veins of silver, their chambers glimmering with frost, remember that they're not cold monuments to technology. They're instruments, delicate harps tuned to the quiet frequencies of the cosmos. Through them, we're learning to read the patterns of entanglement that have always been there, in starlight, in matter, in thought. Each experiment adds another note to our understanding of how information moves, how it hides, how it never dies. The universe remembers, and through science we're learning to listen to that memory. If you sit quietly enough, you might even feel a faint resonance with it. The warmth of your body, the hum of the devices around you, the light falling softly on the walls, all of these are tiny records of interactions stored in photons and atoms, encoded in energy. The air itself remembers where you've been, the sound waves you've made, the breaths you've taken. Memory isn't an invention of biology, it's a property of being. From here, the story opens into the wider fabric that underlies all this, a field that connects every particle and every vibration, an ocean beneath the surface of space. We've touched its ripples before in passing. Now we'll dive into it fully. It's called the quantum field, and within it, everything you've ever known is just a wave, quietly passing through the sea of existence. But before we wade into that infinite calm, take a deep breath and let this idea rest gently in your mind. The universe doesn't forget. It remembers through patterns, through warmth, through you. If you've ever watched the way light filters through morning fog, you'll know how the edges of things soften. The sharp corners of buildings blur, trees lose their crisp outlines. Even your own hand, when lifted, seems to dissolve slightly into the mist. The world doesn't vanish, it just relaxes. This gentle blur is not a flaw. It's what makes the scene feel calm, almost tender. Nature loves soft edges, and at its smallest scales, the universe seems to love them most of all. In the early 20th century, a physicist named Werner Heisenberg discovered a rule so strange that even he had trouble believing it. He found that when you try to measure a particle's exact position, the precise spot where it is, you inevitably lose track of how fast it's moving. And if you try to measure its speed with perfect accuracy, you can no longer know exactly where it is. It isn't because your instruments aren't good enough or because the experiment is clumsy. The limitation is built into the very fabric of reality. The more clearly you know one truth, the more another quietly fades from focus. We can think of this not as a cold mathematical rule, but as a kind of cosmic courtesy. The universe refuses to be fully pinned down, perhaps to keep things from breaking. If you were to imagine the smallest building blocks of matter, electrons for instance, not as tiny marbles, but as shimmering fireflies in a dark room, their dance would never freeze long enough for you to say, "There, right there." The moment you tried to shine a light on one, the light itself would push it, changing its path. The attempt to see alters what's seen. And yet, that same blur, that impossible precision, is the reason you can touch the world at all. If electrons could sit perfectly still, they would fall inward toward the nuclei of atoms, collapsing everything into a dense, featureless clump. The gentle jitter, the uncertainty in their position, keeps them floating at a distance, creating the delicate space that gives atoms size. Matter, in a very literal sense, exists because the universe can't quite make up its mind. Every table, every cloud, every heartbeat relies on this tiny built-in hesitation. When you look up at the stars, you're seeing the glow of this principle on a cosmic scale. The light from those distant suns isn't perfectly precise. It flickers, it wavers, it spreads slightly as it travels. That shimmer is uncertainty at work, stretched across light years. Even the twinkle of starlight through the atmosphere echoes the deeper truth. Nothing, not even the heavens, holds an absolute edge. This might sound unsettling, but uncertainty isn't disorder. It's freedom. It's what allows the universe to breathe. Every motion, every vibration, every act of creation depends on things not being perfectly known. Without that margin of mystery, there would be no rhythm, no transformation, no life. The same way music depends on the silence between notes, matter depends on the unmeasured space between certainties. Heisenberg's insight has often been called the uncertainty principle, but principle makes it sound rigid, like a law carved into stone. It's more like a whisper, a quiet reminder that knowledge has texture. It's never smooth. It's woven with gaps where possibility lives. We sometimes think of understanding as shining a bright spotlight into darkness, but perhaps it's more like lighting a candle in a room full of fog. You see a little more, yes, but the glow also reveals how soft and endless the mystery really is. In daily life, you experience this too. You might try to recall every detail of a day, a conversation, a face, a feeling, but memory itself blurs the edges. You don't fail to remember. You remember as humans are meant to, imperfectly, with space for emotion and imagination to move between the lines. Art works the same way. A painting that leaves out some detail, that lets a brushstroke fade before the shape is complete, often feels more alive than one that insists on perfection. Our minds, like the universe, thrive in partial knowing. This subtle unclarity gives rise to beauty. It's what lets light curve around air, what lets clouds shift endlessly, what lets human hearts forgive. The universe doesn't draw its boundaries in ink, but in watercolour. When two particles meet, they blur into one another for a moment, exchange a pulse of energy, then drift apart changed. You might say that existence itself is made of meetings and partings so fast and delicate that we never see the edges. For centuries, scientists and philosophers dreamed of complete understanding, a final theory, a view of the world so precise that every future event could be predicted. Heisenberg's discovery was a quiet end to that dream. The universe, it turned out, keeps secrets not out of malice but necessity. It doesn't want to be predictable because predictability is stasis. The blur is what keeps the story moving. Without uncertainty, there would be no new chapters, no surprises, no discovery. And there's a gentle lesson in that for us too. In a world obsessed with clarity and control, we sometimes forget the value of the undefined. The moments that shape us most, the choices, the connections, the turning points, are rarely clean or certain. They live in the fog between knowing and not knowing, and maybe that's exactly where we're meant to be. So the next time you find yourself staring into an unanswered question, remember, you're standing in the same mist that holds the atoms together. The fog isn't a barrier, it's the atmosphere of creation. The universe doesn't draw sharp lines because sharp lines would break too easily. Instead, it paints softly, layer upon layer, allowing reality to remain both fragile and unbroken. From here, the trail of ideas leads us gently toward something quieter still, toward the realization that not knowing everything might not be a limitation at all. It might be the reason beauty exists. It might be the reason peace does. Because when you stop demanding perfect answers, the world finally has room to breathe. There's a kind of quiet peace that arrives when you stop trying to understand everything. You might feel it during a walk on a foggy evening, when the world fades at the edges and the horizon melts into the sky. The details disappear, but the moment feels fuller somehow, gentle, infinite, and kind. The same calm exists in physics, tucked within one of its deepest ideas, that not knowing everything is not a failure, but the reason everything exists at all. Uncertainty, as strange as it sounds, is not an error in the universe's design, it's the design itself. If every atom knew exactly where to be and how to move, there would be no room for change. The world would lock itself into one perfect stillness, a frozen sculpture of certainty. But because things are allowed to wobble, to blur, to remain slightly undefined, life has room to unfold. Electrons shimmer instead of standing still. Molecules dance instead of collapsing. Stars breathe instead of burning out all at once. You can think of this uncertainty as a gentle generosity, a built-in grace that lets the universe explore itself. Imagine a painter standing before a canvas. If every brushstroke were dictated, if every colour had to land in one exact place, the act of painting would lose its joy. Instead, art exists because of freedom, a moment when the hand hesitates, the brush drifts, and something unexpected is born. The same freedom ripples through the fabric of reality. The quantum world is the cosmos painting itself, never entirely sure what will emerge, but certain it will be beautiful. This doesn't mean that science has given up on understanding. It means we've learned to listen differently. The old dream of total prediction, of mapping every motion, every heartbeat of the universe, has softened into something wiser. We no longer chase absolute answers. We study patterns, relationships, probabilities. We learn how the fog behaves, even if we can't clear it. That shift from control to curiosity may be one of the most human transformations of all. In our own lives, we often crave the same, impossible precision. We want to know exactly what's coming, to see every turn of the path before we take a single step. But just as light bends and spreads when it passes through mist, our futures blur because they are alive. If everything was certain, there would be no discovery, no wonder, no reason to wake up tomorrow and look again. The gift of not knowing is the chance to keep learning, to be surprised. You might recall the firefly we imagined earlier, darting through the darkness. The reason it keeps glowing isn't to illuminate every corner, but to trace small patterns of light that let you sense the world's shape, without needing to see it all at once. We navigate life in the same way, by flickers, not floodlights. That's how the mind works, and how matter itself seems to move. Art and science, in their quietest forms, both thrive on this principle. A painting that leaves space for the eye to wander feels more alive than one that answers every question. A melody that fades before resolution leaves you listening in your mind, completing the song yourself. The gaps between notes are where emotion hides. Likewise, in physics, the gaps between what can be measured are where existence gathers its meaning. The soft edges of the universe aren't blank. They're invitations. Even dreams live in this space. Every night your brain spins stories without logic, stitching together fragments of memory and imagination. It doesn't need perfect clarity. It needs movement. When you wake, you might not recall the details, but something of their mood lingers. A trace of possibility. A feeling that the world is wider than your waking mind allows. In that way, dreams are little echoes of quantum life, flickers of meaning that don't demand certainty to be real. Heisenberg once wrote that what we observe is not nature itself, but nature exposed to our questioning. The act of asking shapes the answer. It's an idea that sounds almost poetic, that curiosity, not knowledge, is the universe's most fundamental force. Each question we ask carves a path through the haze, and each path changes the shape of the haze itself. It's an endless conversation, and the universe always replies, though never in the way we expect. When you think of uncertainty in that light, it stops being intimidating. It becomes a kind of companionship. The unknown isn't a void waiting to swallow us. It's a friend walking beside us, whispering, "Keep going. There's more to see." There's tenderness in the fact that we'll never reach the end of discovery. The mystery is patient, willing to travel with us forever. You can find traces of that patience everywhere, in the way clouds form and fade without ever settling into one shape, in the way time slips by in waves instead of steps, in the way love itself changes and expands instead of standing still. The same physics that allows particles to blur into probabilities allows human hearts to grow, to forgive, to remain open to surprise. Precision might build machines, but uncertainty builds meaning. When scientists speak of probability, they don't mean guesswork, they mean possibility. The way the world keeps itself alive by refusing to be finished. That refusal is what lets new galaxies form, what lets stars ignite, what lets you breathe. Uncertainty is creation in slow motion. It's the reason a flame flickers instead of standing rigid. It's the shimmer in water, the echo in sound, the pulse of time. So when life feels unpredictable, remember, it isn't broken. It's following the oldest law of all, the law that says perfection is motion. And peace comes not from knowing, but from trusting that not knowing is enough. Precision isn't peace. Certainty is not safety. What endures is the soft balance between the two, a universe that never stops unfolding and minds that never stop wondering. As we drift onward in our journey, we'll turn from this mist of mystery towards something even more intimate, the way uncertainty doesn't separate things but connects them, how two particles, and perhaps two souls, can remain linked across distance and time. But before we go there, breathe for a moment in this truth. It's okay not to have every answer. The night doesn't need to be fully illuminated to be beautiful. Sometimes it's the shadows that make the stars shine. Imagine two tiny sparks of light, born from the same flash of energy, like twins opening their eyes at the same moment. They drift apart, one to the left, one to the right, across an invisible ocean of space. You might expect that after such a separation their lives would be entirely their own. But something astonishing happens. Even when these particles are as far apart as two stars, what happens to one still seems to echo in the other. It's as though they remain quietly aware of each other, a pair of dancers moving in perfect rhythm, even when they can no longer see the same music. This is what scientists call entanglement, a word that sounds complicated but really means togetherness at its most delicate. When two particles interact in just the right way, they don't leave as separate individuals, they leave as halves of one whole. If you measure the spin of one, the other will show a matching pattern, as if they agreed long ago on how to respond. And no matter how far apart they travel, the universe keeps their shared memory alive. Einstein once called it spooky action at a distance, a phrase that still makes physicists smile. But maybe it's not spooky at all. Maybe it's just another way the universe whispers, we are still connected. You can imagine entanglement like a pair of perfectly balanced coins, sealed in separate envelopes. You send one to the far side of the world and you keep the other with you. When you open yours and see it shows heads, you instantly know the other must show tails. There's no message sent, no secret signal. The two results are just part of one pattern, a quiet promise the coins made when they first touched. In the quantum world, that promise holds even when distance stretches into light years. It's not that one coin flips to match the other, it's that both were always part of a single larger story. For a long time, scientists thought this must be an illusion. Perhaps, they said, each particle carried hidden instructions, a secret script telling it how to behave in advance. That would make everything neat again, predictable, comfortable. But when experiments were finally precise enough to test that idea, the universe disagreed. Photons and electrons, when entangled, behave in ways that can't be explained by any hidden script. The pattern of their responses changes depending on how we look, as if the very act of comparing notes rewrites the story. The cosmos, it seems, doesn't keep secrets, it keeps relationships. The strange part is that entanglement doesn't transmit information faster than light. It doesn't break any rules. Nothing travels between the two particles, not even a whisper. What changes is not the particles themselves, but our understanding of them. The universe doesn't think in terms of separate parts. It thinks in wholes. It's as if the boundary between here and there is softer than we ever imagined. As if space isn't a divide, but a kind of fabric that holds everything together. When one corner trembles, the rest feels it instantly, not through speed, but through shared identity. You can see small reflections of this idea in the world, you know. When two musicians play the same song from different rooms, their notes can still harmonize through timing alone. When two people share a deep friendship, one can sense the other's mood even before words are spoken. These aren't quantum effects, of course, but they rhyme with the same truth. Connection is stronger than separation. The universe, at its core, may be less like a machine of parts and more like a web of relationships, an intricate lace of events that hold one another in balance. If you step outside on a clear night, every starlight beam that touches your eyes began in an entangled dance of energy long ago. Nuclear reactions deep in a star's heart, particles colliding, exchanging, sharing. You're seeing ancient communication across billions of miles, a silent orchestra still playing through the void. When you gaze upward, you're not just observing distant suns, you're joining a conversation that began before life itself existed. Every photon that reaches you has been part of countless interactions, each one carrying a faint trace of all it has touched. Modern technology has begun to use these invisible threads. In research labs, scientists create pairs of entangled particles to test the limits of communication and security. They send photons down long cables, even through satellites, orbiting above, to explore the idea of quantum teleportation. Not the movement of matter, but the transfer of state, the sharing of information across distance through correlation. The process works not by sending something from one place to another, but by making two places briefly share the same definition of reality. It's as if 2 points on a map become the same place, just for a heartbeat, before parting again. But even as we build these remarkable systems, the real marvel lies in what they represent, proof that the universe values relationship. Every entangled particle is a reminder that nothing exists in isolation. Every atom in your body, forged in ancient stars, recycled through oceans and air, carries evidence of contact. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was once part of something else, someone else, somewhere else. You are built from the universe's memory of touch. And maybe that's why entanglement feels so familiar, even before you understand the science. On some level, we've always known that distance doesn't erase connection. You can be separated from someone you love by oceans or years, and still feel them move within your thoughts. You can hear a song from your childhood and feel an entire life unfold again inside you. These are human echoes of a cosmic truth, that what has once interacted never entirely forgets. If you close your eyes now and listen, you can almost sense it. The subtle hum of connection threading through everything. The air against your skin, the pulse in your wrist, the faint sound of wind outside your window. All tiny conversations between you and the universe. Each moment of being alive is entanglement in motion, a continual exchange of information and warmth. You're not observing the world from a distance. You're part of the dialogue, woven into the same quiet fabric that ties star to star, particle to particle, heart to heart. The path now carries us toward the next layer of this mystery. How this web of relationships can store information, how it may form the very memory of the universe itself. But before we drift further, let this simple thought settle in your mind. Connection is not magic. It's the most natural thing there is. Every breath, every photon, every heartbeat is proof that the universe is, in its own quiet way, one great conversation, and you've been part of it all along. Imagine standing at the edge of a lake just before sunrise. The air is still, and the surface of the water looks perfectly smooth. You toss in a small pebble, and ripples drift outward in slow, widening circles. Long after the pebble sinks, those ripples are still there, faint, but spreading. That's how the universe remembers. Every interaction, no matter how small, leaves a trace. A conversation between two particles, a beam of a light touching your eye, the whisper of heat between atoms. They all leave, their ripples behind. The universe is full of them, overlapping and interlacing, creating the pattern we call now. In the language of quantum physics, these ripples are called information. Not information in the ordinary sense, not words or numbers or memories you can write down, but the deep kind of information that describes how things relate to one another. When two particles become entangled, the details of their meeting don't vanish once they part. That connection is written into the fabric of existence, like a note added to the grand song of being. This doesn't mean the universe has a mind. It means the universe keeps score, not of actions or intentions, but of relationships. To understand it, think of the night sky again. The light from distant stars that reaches your eyes tonight began its journey long before you were born. Along the way, that light passed through cosmic dust, grazed invisible clouds of gas, perhaps even brushed the gravity of a planet. Each encounter changed it slightly. The colour, the timing, the direction, all quietly altered. The photon carries a story, a memory of every place it has been touched. By the time it meets your gaze, it's not a simple beam of light anymore. It's the last line of a long letter the universe has been writing for billions of years. Modern physicists believe this story never truly ends. Even when a particle is absorbed or an atom rearranges itself, the information, the pattern of relationships, remains hidden in the larger web. Like the echoes of a song that never quite fade, the details of every interaction linger. This is why many scientists now say that reality itself might be made not of matter or energy, but of information. Every atom, every field, every heartbeat could be seen as a line of code in an unimaginably vast program, running in real time. a program that never erases its data. But don't picture this as a cold digital grid. Think of it instead as an ocean of notes, each one resonating softly with the others. Every wave contains hints of every other wave. When you hear a chord, you're not just hearing separate tones, you're hearing the relationships between them, the spaces, the resonances, the shared breath between notes. That's what information is to the cosmos, the resonance between things. Even space and time themselves may be built from this hidden structure. Some scientists suggest that what we call space is nothing more than the memory of connections, the record of how particles once related to one another. In that view, the universe isn't a vast emptiness sprinkled with matter, it's a web of remembered interactions, constantly updating itself. What we experience as motion or change is simply the universe rearranging its memories, turning possibility into history, one gentle ripple at a time. This memory can't be erased, but it can hide. It can sink beneath layers of new interactions like footprints slowly, covered by snow. Yet the information is still there, woven deep into the pattern of everything that follows. This is why scientists speak of information conservation, a soft rule that says nothing is truly lost. Even in black holes, those mysterious places where matter seems to disappear, many believe the information survives, encoded in the faint glow that escapes their edges. The universe forgets nothing. It only transforms. In laboratories around the world, we've begun to use this idea in delicate ways. Quantum communication and encryption rely on entanglement to share information without sending it through space in the ordinary way. Imagine a pair of entangled photons created in the same instant, one staying on Earth, the other sent to orbit in a satellite. By gently measuring one, we can know something about the other instantly, no matter the distance. It's not that a message travelled between them, it's that their connection is the message. This property could someday create networks of communication so secure they can't be intercepted, because the moment anyone tries to look, the pattern itself changes. You can't copy a whisper written in quantum light without leaving a fingerprint on it. There's a poetic comfort in this. The same law that protects information between particles also protects memory in the larger sense. Once something exists, it can't be unmade, only reshaped. The warmth of your breath joins the air, the sound of your voice becomes vibration, the thoughts you share become patterns in the minds of others. In a literal way, nothing you have ever done or said is entirely gone. It disperses, fades, transforms. But the ripples remain, faint but real. The universe, vast as it is, carries every note. When you sit quietly and feel the rhythm of your pulse, you're feeling the trace of countless interactions happening all at once. Molecules vibrating, cells exchanging energy, atoms sharing photons of light. Your very heartbeat is a memory of every star that came before, every fusion of hydrogen into helium, every supernova that scattered the elements from which you're made. You're not separate from the universe's record. You're one of its paragraphs, written in living light. It's humbling, and also strangely tender, to think that the cosmos remembers us. Not individually, not as names or faces, but as patterns, vibrations in its grand and endless music. To exist, then, is to participate in that song. To live is to create ripples that will never entirely fade. From here, the story flows toward the next great mystery. The sea beneath all these ripples, the invisible field that holds the memory of everything and gives birth to every wave. The ancients might have called it the breath of creation. Today we call it the quantum field. Whatever the name, it is the quiet ocean from which all things rise and to which all things return. But before we dive into that deep calm, take one last slow breath and listen to the faint echo that lives in every heartbeat. The universe remembers you, even now, in the same way you remember it, through rhythm, through warmth, through the act of simply continuing to be. Picture yourself standing on the shore at night, listening to the sea breathe in slow rhythm. The water is dark, endless, alive. You can't see the bottom, but you can sense the depth. A quiet pull beneath your feet, an ancient heartbeat hidden under the waves. That's what the universe feels like when you peer deep enough into it. Beneath all the stars, all the matter, all the light, lies something that behaves very much like an ocean, invisible, continuous, and gently restless. Physicists call it the quantum field, but names hardly matter here. What matters is that everything, every atom, every glimmer of energy, every spark of thought, rises from that same invisible sea. In the beginning, scientists thought the world was made of tiny particles, minuscule beads that bounced around and formed everything we see. But as they looked closer, the beads began to dissolve. They weren't solid at all. Instead, they were ripples, vibrations in something deeper, something that fills every corner of space. It's as if the universe decided that instead of scattering grains of sand, it would stretch one continuous sheet of water and let it dance. Every particle you've ever heard of, electrons, photons, quarks, is just a particular pattern in that water, a ripple with its own tone and rhythm. When you switch on a lamp and light spills into the room, what you're really seeing is the electromagnetic field humming, part of that grand ocean vibrating into visibility. When you take a breath, the air isn't made of disconnected particles. It's a set of waves, curling and folding in the field of matter. Even your own body, if you could see it from this deeper view, isn't made of solid pieces. It's a shimmering choreography of waves, organized by invisible rules, holding the shape you call you for a little while before returning to the sea. One of the quietest but most surprising facts about this field is that it never truly rests. Even in what we call empty space, there's motion. Small, spontaneous flickers of energy, appearing and disappearing so quickly that they seem to defy time. They're called vacuum fluctuations, though the phrase sounds colder than the truth. You can imagine them as tiny twitches in the stillness, like the surface of the ocean trembling in moonlight. These small bursts of energy have been detected indirectly through their gentle pressure on the world. In a famous experiment, two metal plates placed very close together feel a faint pull toward each other, as if the empty space between them were breathing. That's the universe reminding us that even nothing is full of something. This realization changes how we think about emptiness. The vacuum of space isn't an empty void, but a living fabric, humming with potential. Every spark of light, every atom, every wave of gravity rises and falls within that fabric. It's not a backdrop to existence. It is existence in its quietest form. You might say that matter and energy are just the ways this cosmic sea chooses to express itself, the ripples that briefly take shape before fading back into stillness. Sometimes, late at night, it helps to imagine the world from that perspective, not as a collection of objects, but as one grand field of motion. You, the air around you, the stars above, the music from your headphones, all are waves in the same continuous sea. They overlap, interfere, reinforce, cancel, and create patterns that shimmer for a time and then dissolve. That's what reality is. Interference made visible. Life, in that sense, is the universe listening to its own echo. Quantum field theory, the formal name for this vision of reality, sounds intimidating, but its message is gentle. Everything is connected by what it shares. The equations describe how fields rise and fall, how ripples form and fade, but beneath the math is a deeper poetry. It tells us that the world isn't made of separate things colliding, but of continuous relationships unfolding. There's no strict border between the particle and the wave, between here and there, between this moment and the next. It's all part of one soft movement, one infinite tide. If you've ever sat beside a lake and watched raindrops fall, You've seen a small reflection of this truth. Each drop sends ripples that meet and mingle with the rest. At first they seem separate, but after a few moments the water smooths out again, and you can't tell where one ripple ended and another began. In the same way, every action in the universe, every heartbeat, every thought, every flicker of starlight blends back into the wider field. The sea forgets the shape of individual waves, but it never loses their energy. Nothing disappears, everything transforms. This vision can be strangely comforting. If you ever feel small or isolated, remember, there's no true emptiness around you. The space you move through is alive with silent vibration. The energy that holds your body together flows seamlessly into the air and back again. When you breathe out, some of the particles, or rather the waves that make up those particles, will one day become part of clouds, plants, maybe even other people. The field doesn't distinguish between you and everything else. It only dances, and yet even as we begin to understand this ocean, new mysteries appear. If the vacuum hums with energy, why doesn't the universe collapse under its own weight? Why does this invisible background hold galaxies apart instead of pulling them together? When scientists add up all the flickers of the field, the total energy comes out far higher than what we actually observe. The difference is staggering, almost too large to imagine, as if the cosmos were balancing on the thinnest thread of precision. This puzzle, often called the vacuum energy problem, reminds us that even as we learn, the ocean keeps its depths. But maybe that's part of its beauty. The quantum field doesn't need to reveal everything at once. It invites us to listen, to sense the rhythm beneath the noise, to accept that understanding can be as gentle as floating. Beneath all the math, all the theory, is a simple truth you can feel. Even in stillness, the universe moves. Even in silence, it sings. As we drift onward, our attention will turn to the paradox of this endless hum, the mystery of a vacuum that isn't truly empty, a quiet space filled with invisible energy that both supports and threatens the existence of everything. But before we dive into that puzzle, take a moment to feel the air around you. It isn't empty, it's the universe, touching you softly through the same field that binds every atom, every star, and every thought. Imagine standing in a quiet room after a long day. You switch off every sound. No hum of a fan, no rustle of air, not even the faint ticking of a clock. You might think that what's left is silence, pure and complete. But listen long enough and you realize silence is never total. There's always a faint shimmer underneath, the tiny buzz of electricity in the walls, the pulse in your ears, the whisper of your own breath. The universe works the same way. What we once called emptiness, the vast vacuum between stars, turns out not to be empty at all. Even in the deepest silence of space, something still hums. For centuries, scientists believed that if you removed everything from a region, all matter, all light, all heat, you'd be left with true nothingness. But quantum physics taught us otherwise. Even when you take away every atom, every flicker of radiation, the so-called vacuum keeps vibrating. Tiny fluctuations rise and fade spontaneously, like the faint ripples that appear on a pond even when there's no wind. Space itself has a pulse. The void breathes. These small flickers are everywhere. They give rise to fleeting pairs of particles, a momentary something from nothing. A particle and its mirror twin briefly appear, borrow a sliver of energy, and then vanish again, cancelling each other out. This happens so often and so quickly that the vacuum becomes a frothing sea of activity, even though to us it looks calm. Physicists sometimes call this zero-point energy, a phrase that means, even at absolute stillness, there's motion. You might wonder how we can know such invisible activity exists. The answer is that we can feel its subtle fingerprints. In one delicate experiment, two polished metal plates were placed very close together, separated by only a few billionths of a meter. Between them, the restless vacuum has slightly fewer possible vibrations than outside. The imbalance creates a tiny push, a whisper of pressure that draws the plates toward each other. This is known as the Casimir effect, but you can think of it simply as space showing that it's alive. The vacuum, in its quiet way, has preferences. If you could see this process directly, it might look like faint sparks flickering through the darkness. Here one moment, gone the next, leaving no trace except the constant background hum of being. These invisible fluctuations are thought to shape the fabric of the cosmos itself. They might even be the reason galaxies formed in the first place. Long ago, when the universe was new and hot, small random variations in this quantum sea were stretched by expansion, leaving behind denser patches where matter could gather. In a sense, we owe our existence to the trembling of nothingness. But the story doesn't end there. When physicists add up all these tiny flickers, every little pulse of energy from every part of the vacuum, the result is absurd. The total energy density of empty space should be so immense that the universe would have torn itself apart instantly after it began. Yet clearly it didn't. Instead, the cosmos expands gently, steadily, as though balanced on the finest edge imaginable. It's as if all that energy is somehow hidden, perfectly balanced against itself. An orchestra of countless notes that cancel into near silence. To describe this, cosmologists use a quiet symbol in their equations called the cosmological constant. You can think of it as a soft pressure that fills all of space, pushing galaxies apart. It's not a force we can touch or see, but its presence shapes everything. If it were a little stronger, the universe would expand so fast that stars could never form. If it were weaker, gravity would pull everything back into a single point. Somehow, it sits at exactly the value that allows beauty, a kind of universal tuning that lets creation unfold. Einstein once called it his greatest mistake, though today we suspect it may be one of nature's most exquisite secrets, the universe breathing just right. This balance is humbling. It reminds us how little we truly know about the energy hidden in what we call nothing. It may be that the vacuum's restlessness is what powers the cosmos' slow expansion, the invisible hand guiding galaxies to drift apart like leaves on a quiet pond. And yet, there's a deeper stillness underneath. The vacuum doesn't roar, it sighs. Its energy is subtle, more like the tension in a held breath than the crack of thunder. If you try to imagine this emptiness, don't picture a dark, cold void. Picture a faint glow you can't quite see, a warmth that never vanishes completely. Every point in space, even the one right where you're sitting, contains this silent shimmer. It's everywhere and always, the unseen heartbeat of reality. You exist not in the vacuum, but as part of it. The same gentle energy that fills galaxies also fills you. The spaces between your atoms hum with the same rhythm that carries starlight across time. When you pause and breathe, the air entering your lungs carries the echo of those fluctuations, particles forming and fading, each one whispering the same quiet story. That emptiness is fertile, that silence contains music, that nothing is never truly nothing. Some people find this realization unsettling, that even nothing is so busy. But you can also see it as reassurance. The universe doesn't waste a single corner of itself. Even in its stillest places, it keeps creating softly, invisibly, patiently. The vacuum is a promise that existence never truly goes dark. And maybe there's a quiet lesson in that for us. When life feels still or empty, when you feel suspended in your own kind of silence, remember that underneath something is still moving. Growth, potential, connection. All of it hums quietly even when you can't hear it. The same physics that fills the vacuum fills your pause, your waiting, your in-between moments. The silence is alive. As we follow this ripple further, our journey will take us into one of the universe's most poetic acts, the art of tunneling, when particles pass through barriers they shouldn't be able to cross, appearing on the other side as if by faith alone. But before we explore that strange courage, take a moment to rest with this thought. The cosmos doesn't draw a line between something and nothing. It only changes the volume of its own song. If you've ever watched morning sunlight spilling through a closed curtain, you might have noticed how it finds its way through even the tiniest gaps. The room may be sealed, but somehow the light always sneaks in, a quiet rebellion against boundaries. In the quantum world, particles behave in much the same way. They don't always stay where logic says they should. Sometimes they simply appear on the other side of a wall that, by all normal reasoning, they could never cross. This graceful defiance is called quantum tunneling, though it feels more like magic than mechanics, a reminder that even nature's smallest pieces know how to move softly through obstacles. In everyday physics, there are rules about what can and can't happen. If a ball doesn't have enough energy to climb a hill, it rolls back down. Simple, predictable. But in the quantum world, predictability is only part of the story. A particle isn't a ball rolling up a hill. It's a wave, a smear of possibilities that extends slightly beyond its apparent limits. That faint tail of probability can slip through barriers, allowing the particle to tunnel through instead of bouncing off. There's no collision, no breaking down of walls, just the quiet fact that boundaries in the quantum realm aren't as solid as they seem. You could imagine it like a dream of motion, a small note of music that continues softly through a closed door, or a mist drifting through cracks where solid air should stop it. The particle doesn't force its way through. It simply exists in such a way that being on the other side becomes possible. The universe, it seems, has a gentle way of saying, sometimes persistence isn't about strength, it's about subtlety. This phenomenon isn't rare or abstract. It happens constantly, everywhere. The very stars owe their light to it. Inside the hearts of suns, atomic nuclei move with energies far too low, by classical rules, to collide and fuse. Yet they do, billions of times each second. Quantum tunneling lets them pass through their mutual barriers, joining together to create the energy that warms the galaxies. Every sunrise you've ever seen, every breath of warmth on your face, began as a miracle of probability, a quiet yes whispered through the walls of impossibility. The same quiet defiance shows up closer to home, in the devices we hold and use every day. The transistors that form the heart of computers and phones rely on electrons tunneling through thin layers of material. The tunneling microscope, a tool that lets scientists see individual atoms, works by measuring the faint electric current that flows when electrons tunnel between a sharp tip and a surface. Even the simple act of your body generating energy, the chemical reactions in your cells, depends on electrons moving through barriers in this subtle way. The world you know isn't built despite tunneling, it's built because of it. If you could shrink yourself to the scale of a single particle, you'd find that motion itself feels very different. There are no clear lines saying, you must stop here. Everything blends, overlaps, trembles a little at the edges. When the wave of a particle encounters a barrier, part of it reflects, but part of it lingers, stretching its presence into the forbidden region. Most of the time, that stretch fades to nothing, but sometimes just enough of it survives to appear on the other side. There's no dramatic crossing, no explosion of energy, just quiet continuity. The particle never really leaves one place and enters another. It simply extends its existence a little further until the impossible becomes ordinary. There's a quiet lesson there, one that goes beyond physics. The universe seems to prefer progress that's patient. When faced with a barrier, it doesn't always smash through. Sometimes it waits, it hums, it expands its presence just enough to appear on the far side, changed but unbroken. That's tunneling. It's persistence without violence, determination written in softness. Think of how many parts of life follow this pattern. Ice melts not because it fights the cold, but because warmth seeps in molecule by molecule. Mountains wear down not by sudden collapse, but by centuries of wind and rain. Even in human lives, the greatest transformations rarely happen through force. They happen when we linger at the edge of what seems impossible long enough for possibility to quietly reappear. The boundary that felt solid begins to soften, and one day we find ourselves on the other side, unsure how we got there, but grateful we did. Scientists once tried to express tunneling through equations, but it might be simpler to think of it as the universe's version of faith, not belief without evidence, but motion without guarantee, a willingness to let probability open doors where certainty can't. The math says it's a consequence of the wave behaviour, but the feeling it evokes is older than math. It's the same instinct that lets a seed push through soil or light slip through cracks. The same gentle persistence that has guided the universe from its first heartbeat. Even decay, the quiet breaking down of matter, owes its grace to this process. When a nucleus releases energy and transforms into something new, it often does so by tunneling, not tearing itself apart, but softly allowing a piece of itself to drift beyond the barrier that once held it. Change, it seems, isn't destruction, it's permission. The universe grows by allowing things to pass through their limits, to find what lies beyond. If you close your eyes now and listen, you might feel a faint echo of this principle inside you. Every breath, every thought, every moment of growth is a kind of tunneling, a way of passing through uncertainty without needing to break it. The barriers in life are rarely as firm as they seem. Sometimes, the way forward is not to push harder, but to expand softly, to let yourself exist on both sides of the wall until the wall itself gives way. So when you face something that feels impenetrable, a dream that feels too far, a fear that feels too heavy, remember how the universe itself moves. Remember the particles that pass through mountains of probability every second just to let the stars shine. Persistence doesn't have to roar. It can whisper. It can glow. It can move through the impossible the way light seeps through a curtain. Patient and sure. Our story will soon rise from the invisible to the visible once more, to the way these small quantum miracles weave together to build worlds, chemistry and colour, and to the strange bridge between the quantum and the cosmic. But before we step back into that grander scale, let this moment rest in your thoughts. The universe doesn't always conquer barriers. Sometimes it simply dissolves them, one quiet probability at a time. Imagine walking into a library so vast that you can't see its end. Shelves stretch into the horizon, stacked with every possible story ever written, and every story that could be written but hasn't been yet. You're here to find one specific book, the one with the answer you need. In a normal library, you'd wander aisle after aisle, pulling one book at a time, flipping pages, searching line by line. It would take forever. But in this strange, quiet library, something magical happens. Every book opens itself at once. Every word is read simultaneously. The answer gently rises to meet you, as if the library itself has already thought it through. That is what a quantum computer feels like. It doesn't work by brute force, checking each possibility in order. Instead, it explores all possibilities at once, a kind of calculation that hums in parallel across reality, not by magic, but by the logic of uncertainty itself. Traditional computers live in a world of ones and zeros, of switches that are either on or off. Quantum computers, by contrast, live in a world of maybe. Their smallest units of information, called qubits, can be both 1 and 0 at the same time, like a coin spinning in midair. Only when the computation is finished, when we look, does the coin land, revealing a final answer drawn from all the possible paths it took along the way. If ordinary computers are like readers following a single line of text, quantum computers are like dreamers, holding an entire book in their minds at once, letting meaning unfold softly through patterns rather than steps. That's the quiet miracle of quantum logic. It doesn't discard uncertainty, it uses it. You can picture a qubit as a shimmering coin suspended above a table. Its state isn't heads or tails, but a dance between the two. Every qubit adds new dimensions to this dance. 2 qubits can hold 4 possibilities at once. 3 can hold 8, 20 can hold over 1,000,000. The possibilities don't multiply like simple numbers. They expand like light across glass, overlapping, amplifying, cancelling, reshaping. That's how quantum computers can, in theory, solve problems that would take classical machines the age of the universe to even attempt. But what's most beautiful about this isn't speed, it's subtlety. The quantum world doesn't think in the language of commands and results. It thinks in interference, in the quiet balance between alternatives. You can imagine each possible outcome of a problem as a soft wave. These waves ripple together, meeting and merging. When they overlap in harmony, they strengthen. When they contradict, they fade. At the end, only the correct path remains clear, not because it was forced, but because it resonates. A quantum algorithm, at its heart, is a kind of music. Some of the earliest examples of this music are called Shor's algorithm and Grover's algorithm. But rather than treat them as mathematical procedures, you can think of them as stories. Shor's algorithm is the story of a lock with a secret key, one so complex that a normal computer would spend centuries trying every combination. The quantum machine, instead, hums through all possible keys at once, letting the wrong ones cancel out until the right one sings alone. Grover's algorithm is the story of a labyrinth with countless paths. A normal traveller might wander for ages, but a quantum traveller walks every path in parallel, listening for the one that echoes differently, the one that leads out. Both tales share the same moral. The universe, when allowed to compute in its own language, does not need to search. It feels, it resonates, it listens to itself. And yet, this isn't sorcery. The power comes not from breaking rules, but from honouring them, from working with the natural uncertainty that every atom already carries. It's as though we've finally learned how to borrow the logic of the universe itself, letting our machines dream in the same way the cosmos calculates. For the first time, we are building technology that doesn't fight quantum strangeness. It embraces it. Still, the process is delicate. A qubit's graceful spin can be ruined by the slightest noise, a vibration, a stray photon. To preserve the fragile balance between its possible states, quantum computers are built in silence, often cooled to temperatures colder than outer space, where atoms hardly move at all. There, in that near absolute stillness, qubits hum softly in the dark, hovering between worlds of yes and no. If you could stand beside one of these machines, beneath its golden towers of wiring, where streams of liquid helium flow in quiet spirals, you wouldn't hear computation the way you hear fans and processors whirring. You'd hear nothing. The real work happens in whispers too faint for ears, too gentle for sound. It's computation by stillness. The universe doing what it already does, guided by human curiosity and care. This idea changes how we think about logic itself. For centuries we imagined intelligence as a ladder. Step after step, rule after rule, precision conquering ambiguity. But quantum logic suggests that intelligence might also live in hesitation, in allowing multiple answers to exist until the truth reveals itself through harmony. It's a lesson both scientific and human. Sometimes clarity is born not from choosing, but from letting possibilities coexist long enough to resonate. You can feel this in ordinary life too. When you face a difficult choice, your mind doesn't instantly pick one path. It drifts, it weighs, it imagines. In those moments, you're thinking like a quantum system, holding many options at once until one feels right. Decision-making, creativity, intuition, they're all quiet computations of probability and resonance. The same principles that guide the tiniest particles also guide your heart and your mind. And maybe that's the most poetic part of all. The machines we're building, these quantum computers, aren't so different from ourselves. They too are learning to balance possibility and certainty, to dream in maybes before deciding. They mirror the way the universe itself unfolds, not through binary steps, but through soft patterns of probability, interference, and emergence. In a way, quantum computing is humanity's most humble act of imitation. We've stopped trying to force the universe into our logic and begun to listen to its own. We've learned that sometimes the fastest way to the truth is to let the truth find its own harmony. As we drift further into the story, we'll see what these machines look like. The delicate frameworks of metal and light that keep their qubits alive. The frozen stillness where thought itself becomes vibration. But before we step into that cold, humming chamber, pause for a moment and hold this image. A library where all books are read at once, where knowledge is not taken but revealed. That's the promise of quantum computing. Not speed, not power, but the rediscovery of wonder, written in the language of maybe. If you could step inside a quantum computer, the first thing you'd notice is the silence. There are no fans whirring, no mechanical clicks or flashing lights. Just an otherworldly stillness, the kind that makes you instinctively lower your voice, as though entering a cathedral. Suspended above you are golden towers of wire and copper, shaped like delicate chandeliers. Inside those towers, in chambers colder than deep space, a handful of atoms hum so softly between two states that even the slightest vibration could break their spell. This is the strange heart of quantum computing. Machines that think not in ones and zeros, but in shimmering probabilities. At first glance, it might look like science fiction. Rows of cables lead to a cylindrical core wrapped in shimmering insulation. Yet at the centre of that frozen architecture, what's happening is more poetic than mechanical. Each tiny unit of information, each qubit, is balanced in a fragile dance between opposites, holding all its possible truths at once. To keep that balance alive, the entire system must be shielded from the world. A single, stray photon, a hint of warmth or a microscopic tremor could destroy the quiet superposition that allows it to think. That fragility is known as decoherence, though we might think of it more gently as the breeze that ruins a dream. Decoherence happens when the delicate quantum music becomes entangled with its noisy surroundings, when the world outside intrudes on a thought too soft to survive contact. In a sense, quantum computers dream, but the dream is so easily disturbed that it must happen in a perfect hush, behind layers of shielding and cold. Engineers fight this fragility with patience, designing systems that hover within fractions of a degree above absolute zero, where atoms nearly stop moving, where silence itself becomes a tool. Inside this deep cold, qubits live in many forms. Some are tiny superconducting loops, rings of metal so pure and cold that electrical current flows endlessly without resistance. Others are single ions, caught in place by beams of light, suspended like dew in invisible webs. Some are even photons themselves, particles of light whispering down glass corridors, encoding information in their polarizations and phases. No matter the method, the principle is the same. Use the language of the universe's smallest particles to perform the gentlest calculations imaginable. When a quantum computer begins its work, it doesn't count, compare, or sort in the way a classical one does. It prepares a delicate chorus of qubits, each one vibrating through all its possibilities. They influence one another, weaving a network of correlations, a cloud of ABs so rich and precise that the answer hides inside it like a melody waiting to be found. The trick is to let the system evolve just long enough for those overlapping possibilities to interfere, amplifying the right patterns and cancelling the wrong ones. When the computation ends, the machine measures its qubits, and the cloud of possibilities collapses into a single outcome. To outsiders, it might look like magic, but it's not magic, it's choreography. Each qubit dances to the rhythm of the field it inhabits, every step guided by subtle pulses of microwaves, lasers, or magnetic fields. The pattern is precise, the timing exquisite. When it works, you can almost imagine the machine listening, not with sensors or code, but with attention, as if waiting for the right harmony to emerge. You could think of decoherence then, not as failure, but as the world's insistence on being part of the conversation. Every qubit wants to share its state with its surroundings, to interact, to belong. Our challenge is simply to help it stay alone long enough to whisper its answer. The balance between isolation and connection is the essence of both quantum computing and, perhaps, intelligence itself. To think clearly, you sometimes have to be very quiet. It's astonishing to realise that we've reached this point, where our machines are cooled to near absolute silence, just so they can think in the same language as starlight and atoms. The coldness isn't cruelty, it's care. It's how we make space for possibility to survive. In those frozen chambers, the logic of the universe itself unfolds, not in words or numbers, but in waves of probability, in whispers of maybes that gradually find their way to truth. And yet, despite their promise, these machines remain profoundly human. They stumble, they forget, they decohere. They remind us that progress is never about conquering uncertainty, but learning to live alongside it. Each experiment, each flicker of success, is a small dialogue between human patience and cosmic law. When a calculation finally works, when a quantum computer solves something that once seemed unreachable, it feels less like victory and more like cooperation. The universe has allowed us to borrow its own logic for a moment, to think as it does, softly, in parallel and with grace. Someday, when these machines grow steadier and less fragile, they may change everything, from medicine to climate prediction to the mysteries of chemistry and life itself. They will model molecules atom by atom, design materials from the vacuum up, and search patterns in data that no ordinary processor could even see. But the real transformation may not be in what they calculate, but how they do it. They're teaching us that thinking doesn't always mean dividing the world into neat categories. Sometimes it means holding contradictions in balance, letting multiple truths coexist until clarity emerges on its own. It's a lesson that extends beyond laboratories. The next time you find yourself trying to solve a problem, not with technology but in your own life, consider this. The answer might not come from analysis, but from resonance. Let ideas overlap. Let feelings interfere. Let uncertainty hum for a while. The universe doesn't always rush to resolve its maybes. It lets them linger until something beautiful appears. In the end, that's what these machines truly represent. Not power, but patience. They're our first instruments built to think in shades of possibility, mirrors of the cosmos itself, shimmering between being and becoming. In their frozen silence, they remind us that the boundary between logic and imagination was never solid. It was always a spectrum of light, flickering quietly beneath our understanding. Our journey now turns toward life, toward the green and golden world above those laboratory floors, where sunlight and cells have been performing quantum feats since long before we gave them names. Before we ever built machines that dream in maybes, nature was already doing it. Inside leaves, inside eyes, inside you. But before we follow that living thread, take a breath and imagine one last image, a machine, cold as starlight, thinking not in black or white, but in infinite hues of maybe, quietly reflecting the mind of the universe itself. If you step outside on a warm morning and watch sunlight filtering through leaves, you're already seeing quantum mechanics at work. Not in the stars, not in machines, but in the veins of living things. That shimmer of green, that effortless act of turning light into life, hides a secret older than biology itself. Every plant, every blade of grass, every tree swaying quietly in the wind is performing a miracle that science still struggles to fully explain. The conversion of sunlight into energy with almost perfect efficiency. And the trick behind that miracle, strangely enough, might come from the same rules that govern the smallest particles of the cosmos. Deep inside a leaf, beneath layers of cells, there are tiny structures called chloroplasts. Within them, light particles, photons, are caught and handed to molecular networks that move the captured energy toward the heart of the plant, where it will be stored as sugar. You might imagine these energy transfers as simple mechanical steps, like buckets passing water down a line. But when scientists peered closer, they found something far stranger. The energy doesn't travel along a single fixed path. It seems to explore every possible path at once, searching, feeling, finding the fastest route through a tangled maze of molecules. This is what physicists call coherence, though the word sounds colder than what it means. You can picture it instead as a choir of vibrations moving together in rhythm, each molecule briefly joining a collective hum that lets energy glide through the network instead of stumbling. It's as though sunlight itself, once absorbed, takes a moment to listen, to hear all the ways it might reach its destination, and then chooses the most elegant one. It's a quiet example of quantum efficiency, hidden inside something as familiar as a leaf. And here's the real wonder. This process happens in warm, messy, noisy conditions, in water, in sunlight, amid molecules that should, by all logic, scatter coherence in an instant. The fact that this delicate quantum rhythm survives at room temperature inside living tissue is astonishing. It's like a symphony playing flawlessly in the middle of a thunderstorm. Somehow, life has found a way to protect that harmony long enough to make use of it. When you think of it this way, photosynthesis isn't just chemistry, it's choreography. The light absorbed by a leaf doesn't crawl along a molecular track, it dances. It ripples across possibilities like a musician improvising a melody that finds its resolution only when it reaches the plant's reaction center. What would take brute energy if done classically is done with grace, almost effortlessly. A single photon of sunlight travelling for 8 minutes from the sun to Earth ends its journey by becoming part of a rhythm that sustains nearly every living thing on this planet. It's humbling to realise how deeply this quiet dance connects everything. The breath you take right now began as a quantum event, a photon deciding through probabilities how best to reach its goal. The apple on your table, the oxygen in your lungs, the warmth in your blood, all trace back to those invisible acts of coherence that happen millions of times per second in every forest, every garden, every patch of green. For years, scientists thought the messiness of life would destroy such delicate quantum effects. But it turns out that life thrives because of that messiness. The gentle jostling of molecules, the heat, the motion, the vibration, helps reset the system, keeping it poised between order and chaos. It's a kind of natural tuning, a balance that allows quantum rhythm to survive just long enough to do its work. The noise, rather than breaking the music, becomes part of its tempo. You might compare it to the way human creativity works. A mind that's too rigid loses its spark, one that's too chaotic loses direction. Somewhere between focus and freedom, ideas begin to flow. Photosynthesis lives in that same sweet spot, structured, enough to be precise, flexible enough to adapt. The universe seems to love this middle ground, the place where order meets chance, where rules and freedom coexist. It's possible that quantum mechanics supports more of life than we realize. Some researchers suspect similar effects may play roles in the way we smell, how enzymes trigger reactions, even how our own cells convert energy. Though much remains uncertain, what's clear is that living matter hasn't left quantum physics behind. It's made peace with it. It's learned to cooperate with uncertainty, to use coherence without collapsing it. Life, in its quiet wisdom, uses the same laws that govern the stars to keep itself alive. There's a beautiful symmetry in that thought. The same equations that describe electrons in atoms also describe sunlight gliding through leaves. The same probabilities that shape a photon's journey through space shape your heartbeat, your breath, your very metabolism. The difference is only in scale. Life at every level is the universe learning to self-organize, to find patterns of stability in a sea of change. If you step back for a moment and watch sunlight ripple across a tree canopy, you can almost feel that invisible web connecting everything. The photons, the leaves, the air, the tiny vibrations between molecules. It's not abstract. It's happening in real time, billions of times per second, right before your eyes. It's a kind of quiet communion between light and matter, an ancient conversation still continuing from the dawn of creation. And perhaps, if you listen closely enough, you can sense what that conversation is saying, that life isn't an accident of physics, but one of its most graceful expressions, that the same strangeness we study in laboratories is what makes your garden grow, what lets birds migrate, what lets you breathe. Quantum mechanics isn't just beneath the stars, it's beneath your skin. Our path now carries us toward one of the most poetic examples of all, a mystery that lives in the eyes of birds. Somehow, creatures as small as robins can read the invisible patterns of Earth's magnetic field and find their way across oceans. And the secret, once again, may lie in the gentle bond between particles, in the same kind of entanglement that connects stars and photons. But before we follow that thread, take a slow breath and remember, every breath of oxygen you take began as a quantum choice made in sunlight. Life, it seems, has always known how to think in probabilities. On early spring mornings, when the air is still pale with cold, you might see a robin perched on a fence, head tilted toward a direction it somehow just knows. The sky's grey, the sun barely awake, and yet that small creature seems certain of its path. Year after year it will travel hundreds, even thousands of miles, crossing fields, rivers, oceans, guided not by landmarks or stars, but by something far more, invisible. Somewhere inside that tiny body, inside one of its eyes, there's a compass that doesn't point north through metal or magnets, but through the faint whisper of quantum entanglement. It sounds almost unbelievable that a living creature could rely on a quantum effect to find its way through the world, yet the evidence is growing. At the centre of this mystery lies a delicate molecule called cryptochrome, nestled within the robin's retina. When light enters the bird's eye, it excites this molecule, freeing two electrons that instantly become entangled, their spins linked in perfect harmony, even while they sit on different parts of the molecule. Together, they act as a kind of living sensor, reacting to Earth's magnetic field in ways that subtly alter the bird's perception of light. To the robin, the sky doesn't just appear as blue or grey. It shimmers faintly with invisible gradients of brightness, a quiet overlay of direction. Where you and I see empty air, the bird sees a map drawn in magnetic ink, one it reads effortlessly with every beat of its wings. This process is astonishingly delicate. Entanglement, as you may remember, is fragile, easily broken by heat, motion, or noise. Yet inside the warm, wet chaos of a living eye, these entangled electrons manage to stay coherent just long enough to do their work. For a few billionths of a second, an eternity by quantum standards, they whisper across distance, comparing notes before the signal fades. And in that whisper, the bird knows where home lies. It's as if nature itself built a quantum sensor long before we learned to do so in our laboratories. Engineers struggle to maintain coherence in perfectly controlled chambers, cooled to near absolute zero, while a robin, without knowing it, carries out the same feat mid-flight, buffeted by wind and rain. There's a quiet humour in that. We've spent decades learning how to preserve entanglement in metal and silicon, while a bird does it casually between wing beats. Scientists aren't entirely sure how the mechanism works in detail, and that mystery only deepens the wonder. Perhaps the cryptochrome molecules align themselves in the eye like a living compass rose. Perhaps the changing spin states of the electrons alter the bird's neural signals directly, blending vision and navigation into one seamless sense. Whatever the exact process, the outcome is astonishing. A biological instrument sensitive enough to feel the Earth itself. If you could borrow that sense for a moment, imagine what you'd see. The world around you would glow faintly with direction, not as arrows or signs, but as soft hues overlaying the landscape. North might appear as a faint blue tint, south as a gentle gold. Each turn of your head would shift the light slightly, as though the planet itself were brushing your vision with invisible fingers. That's how a robin perceives the sky. Navigation isn't thought for it, it's sight, and this ability isn't unique to one species. Many migratory birds, warblers, thrushes, even tiny garden songbirds, carry the same invisible compass. Some fish and insects show signs of similar navigation. It's possible that entanglement, that quiet quantum partnership between electrons, hums within countless eyes and wings around the world, a shared inheritance written into life itself. The idea reshapes how we think about biology. It suggests that evolution didn't stop at chemistry and mechanics. It reached down into the quantum realm, using the uncertainty and coherence of particles as raw material for new senses. Nature, it seems, has always been a quantum engineer. There's something beautifully poetic about that. A robin flying through a storm doesn't know about spin states or magnetic fields. It only knows direction, the quiet pull that tells it which way home lies. And yet, in obeying that pull, it's performing one of the universe's most intricate calculations. Each beat of its wings is informed by particles linked in a bond so subtle that even the universe itself treats it with care. When you think of it that way, migration becomes more than a biological event. It becomes a collaboration between sunlight and molecules, between the Earth's magnetic heartbeat and a creature's instinct. The bird doesn't conquer the laws of physics, it flows with them, it listens to them, it carries the language of the quantum world in its feathers. You might wonder what it feels like to sense a field you can't see, to follow a compass that isn't mechanical but woven into your very perception. Perhaps it feels like faith, not faith as belief, but faith as trust. Trust in the invisible, in the patterns that guide without being seen. The robin doesn't question the pull of the field any more than you question gravity. It simply follows, confident that the unseen hand of the earth will keep pointing the way. And perhaps that's why this story resonates so deeply with us. We too move through a world guided by invisible fields, not magnetic but emotional, relational, gravitational in their own ways. We follow intuition, memory, hope. We sense connections we can't always explain, and somehow they lead us where we need to go. The physics of the bird's eye becomes a metaphor for the physics of being alive. Next time you see a small bird perched on a wire, eyes tilted toward the wind, take a moment to imagine the quiet miracle inside it. Two electrons still whispering to each other across distance, aligning with the planet's field, creating a map that no human eye could see. Nature invented quantum navigation long before we named it, and it did so not through machinery, but through elegance. Our path now opens wider, from the microscopic and the winged to the cosmic and the elemental. We've seen how quantum laws pulse within living things. Now we'll see how those same laws write the chemistry of matter and the structure of stars, how the dance of electrons builds colour, music, and life itself. But before we rise into that vastness, take one more breath and look at the sky. Somewhere, a robin is flying through it, tracing invisible lines only it can see, guided by quantum whispers that never lose their way. If you could look deep inside a single atom, not just at its nucleus or its electrons, but into the pattern that holds it together, you'd find something both astonishing and strangely familiar. It's not a machine of gears and bolts, nor a tidy orbit like planets circling a sun. It's more like a symphony, with each note defined not by its position, but by its permission. Electrons hum in regions called orbitals, but those aren't places in the usual sense. They're patterns of possibility, soft, glowing clouds that show where an electron might be found if you asked. The rule that governs them is simple but profound. No two electrons can share exactly the same state. Each one needs its own seat at nature's dinner table. This quiet courtesy is known as the Pauli exclusion principle, but you can think of it as the universe's way of keeping the conversation civil. If all the electrons tried to sit in the same chair, chaos would follow. Instead, they spread out, forming the layered shells that make atoms distinct. The structure of every element, from hydrogen to gold to the iron in your blood, exists because nature insists that every participant have its own space to be. You could imagine it as a cosmic seating chart, written in energy rather than ink. The lowest seats are closest to the atomic heart, where electrons hum with calm efficiency. Higher seats lie farther out, where they spin with more energy, sometimes trading places, sometimes sharing a rhythm across atoms to form bonds. Chemistry, in its essence, is the art of these shared dances. When two atoms bond, they're not colliding like billiard balls. They're synchronizing their electron songs. Bonds are harmonies, not collisions. That's why molecules can be so beautiful. The shapes they take, spirals, rings, lattices, are the geometry of shared vibration. Carbon, for instance, builds endlessly varied structures because its electrons can sing in multiple registers, harmonizing with many partners at once. Water, simple as it is, owes its liquid grace to a subtle asymmetry in its electron duet. Even your DNA, the coiled staircase of life, is a story written in these soft electromagnetic notes. You are, in a very real way, a song made of atoms learning how to cooperate. All this order depends on quantum rules that would seem absurd from a classical point of view. Without uncertainty, electrons would fall into the nucleus. Without exclusion, all matter would collapse into a single, featureless lump. The solidity of your chair, the sharpness of salt crystals, the glint of metal, all exist because electrons politely refuse to crowd. Nature builds its strength from boundaries made of courtesy. But the story stretches far beyond chemistry. Those same rules that shape the structure of atoms also shape the fate of stars. Inside a sun, gravity is always trying to crush matter inward. Fusion pushes outward, balancing the weight with light and heat. But when a massive star exhausts its fuel, gravity wins. The core begins to collapse, atoms breaking, protons merging with electrons, leaving behind a sea of neutrons packed tighter than imagination allows. At that moment, a new quantum law takes over, the same exclusion principle, now applied to these heavier particles. They too refuse to share the same state. Their resistance halts the collapse, forming what we call a neutron star, an object so dense that a teaspoon of it would outweigh a mountain, yet so stable that it can spin for millions of years. This delicate balance, between pressure and collapse, between quantum rules and cosmic gravity, is what keeps the universe from tearing itself apart. Even the death of stars obeys the same principles that shape your atoms. The cosmos, at every scale, hums to one rhythm. When a star dies, it leaves behind more than light. In the furnace of its final moments, the extreme heat and compression fuse lighter elements into heavier ones. Carbon, oxygen, silicon, iron, gold. The dust of those dying stars drifts through space, gathering again into new clouds, New worlds, new lives. The iron in your blood was born from the heart of a collapsing sun. The calcium in your bones once glittered in the shell of a supernova. Every breath you take carries the ghosts of stars that lived and died long before Earth existed. And still, the story goes deeper. Long before stars were born, the universe itself began as a quantum fluctuation, a tremor in the vacuum, a tiny imbalance that expanded into everything. The galaxies we see today, the clusters and filaments that stretch across billions of light years, all trace their origins to those microscopic ripples in the energy field of the early universe. The same uncertainty that gives electrons their shimmer also gave the cosmos its structure. The great and the small are written in the same hand. It's hard not to feel wonder at that symmetry. The rules that keep a leaf green are the same that ignite the stars. The uncertainty that allows electrons to move without collapsing is the same uncertainty that allowed galaxies to form from emptiness. Even now, the balance between order and chaos, expansion and collapse, plays out on every level of existence, from the chemistry in your cells to the birth of new suns. You might think of it as the universe breathing, inhaling structure, exhaling energy, creating and dissolving forms like waves on an eternal shore. Each wave is a moment of balance between opposites, a pattern that appears briefly and then blends back into the sea. You are one of those waves, a structure held together by quantum principles, by probability and grace. The same mathematics that describe an atom's orbit describe the glow of a nebula. The same physical limits that give you mass also hold the stars in place. If you close your eyes and imagine this, you might feel less like a spectator of the cosmos and more like part of its rhythm. Every atom in your body carries a memory of the universe's early tremors, an echo of the moment when possibility first became form. You are quite literally the universe remembering its own beginning. From here, our journey will turn softly toward meaning, to how all these rules, as strange and impersonal as they may seem, become the quiet poetry of existence. We'll untangle the myths, the misconceptions, the ways we've tried to make the quantum world either too magical or too mechanical. But before we do, take a moment to sit with this thought. You are made of starlight and uncertainty, of particles that have danced since the dawn of time, obeying rules older than galaxies, and somehow out of that, you can look up and wonder. There's something about the word quantum that stirs imagination. It has become a kind of modern magic, a symbol of mystery, of things unseen. You'll hear it in conversations about consciousness, spirituality, even luck. Quantum has come to mean anything strange, anything that defies logic. But the true wonder of quantum physics is gentler than magic and far more grounded. It doesn't promise miracles. It promises understanding, a deeper look at the threads that connect everything without needing to pull them into superstition. It's easy to see why the myths grew. The quantum world is a place where particles can be in two places at once, where observing something changes what it becomes, where distant objects seem to share thoughts across space. It sounds supernatural, as though reality itself were waiting for our gaze to solidify. But if you listen closely to the science, to the soft voice beneath the equations, you'll find that what it's saying isn't mind over matter, but something more tender, relationship over isolation. Let's start with the most common story, the idea that our thoughts directly control the physical world. It's a beautiful dream, and in a way, it's not entirely wrong. Observation does matter, but observation in quantum physics doesn't mean conscious mind. It means interaction. When a particle meets another, when light hits an atom, when an electron touches a detector, that's an observation. No awareness required, no cosmic attention necessary. The world doesn't wait for us to look at it before it exists. It exists by looking at itself. Every atom, every photon, every grain of dust is constantly observing and being observed through contact, You can imagine it like this. Reality isn't a painting on the wall waiting for an audience. It's a conversation. Continuous, self-sustaining, and endless. Each exchange between particles adds a word, a phrase, a small sentence to the ongoing story of existence. Consciousness joins in that dialogue, yes, but it didn't start it. The universe has been speaking softly to itself for billions of years, and we are one of its later sentences, meaningful but not the first. Another myth tells us that entanglement means faster than light communication, that two particles can send instant messages across space. The truth is quieter and even more profound. Entanglement doesn't carry signals, it carries connection. It doesn't break the cosmic speed limit, it bypasses the need for it entirely. When two particles become entangled, they aren't sending messages, they're sharing a state. Measuring one simply reveals what was already part of a larger whole. It's not about distance being conquered, it's about distance being irrelevant. The universe doesn't have to send information between its parts because on some level, there are no parts. Then there's the story of Schrödinger's cat, perhaps the most misunderstood of them all. In the thought experiment, a cat inside a box is said to be both alive and dead until someone opens it. Many people think this means that reality exists in a ghostly half state, waiting for our decision. But that was never the point. Schrödinger proposed it to show how absurd quantum rules would sound if we tried to apply them directly to big, everyday things. In truth, the cat is never both alive and dead. The box contains a delicate quantum process that quickly becomes tangled with the larger, noisier world. The air, the walls, the heartbeat of the observer. By the time you open the box, the quantum possibilities have long since collapsed into one reality or the other. The thought experiment wasn't meant to mystify physics. It was meant to remind us of its boundaries. And then there's the notion that quantum mechanics is chaotic, that it replaces order with randomness, that the universe is just rolling dice. But look closer, and you'll see that what we call randomness isn't lawlessness. It's structure so fine we can't trace it. The probabilities in quantum theory aren't guesses, they're patterns. The universe doesn't gamble, it plays an intricate game of music, one where uncertainty is the rhythm, not the flaw. When a particle's path seems uncertain, it's not because it's lost, it's because it's participating in a pattern too rich to follow step by step. Another myth, gentler but still misleading, says that quantum physics means anything goes, that we can make up our own truths because the universe is fluid. But the quantum world, for all its mystery, is astonishingly disciplined. Every measurement, every outcome follows precise mathematical harmony. The rules are strict, almost musical in their consistency. They don't bend to our wishes, they shape what wishing itself can mean. Freedom exists, but within rhythm. Creativity flourishes, but inside boundaries. Even uncertainty has structure. So what, then, is the soft truth of reality? It's that the universe is participatory, not because it needs us, but because everything within it is connected. Every atom, every flash of light, every moment of awareness is part of a shared process, an endless web of relationships. You don't stand outside it, observing from afar. You're within it, as much a part of its conversation as any photon or wave. Reality isn't a stage, it's a dance floor, and you've been dancing all along. The beauty of this truth is that it strips away both arrogance and despair. You don't control the universe with your mind, and you're not powerless before it either. You're part of its flow, a participant in the great exchange of being. Your thoughts, your breath, your choices all ripple outward in the same quiet way quantum effects ripple through space. Not by command, but by connection. Not by dominance, but by resonance. If there's a lesson in all this, it might be that understanding doesn't mean taking mystery away. It means learning to live with it, to hold clarity and uncertainty in the same breath, to find peace not in answers, but in participation. The universe is not made of separate objects obeying abstract rules. It's made of patterns that know one another, weaving themselves into existence with every interaction. You're one of those patterns, a temporary, luminous arrangement of probabilities and memory. Every cell in your body is the result of quantum cooperation. Every thought is a wave collapsing into form. The atoms that make you once lived in the hearts of stars, and the light that touches you now, began its journey before there was a human eye to receive it. When you look around, you're not seeing things. You're seeing relationships made visible. The universe recognizing itself again and again. And so, as our long journey draws to a close, return for a moment to the beginning, to that first question that brought us here. Is reality fixed, or does it crystallize only when we look? The answer, whispered softly through all of physics, is both. Reality is steady enough to hold us, yet fluid enough to respond when we reach for it. It's participatory, but not personal. Intimate, but not owned. The universe isn't made of things. It's made of stories, of patterns, of probabilities. And you, dear listener, are one of them. A ripple in the great wave, a thought the cosmos is still thinking.